So I'm sharing my screen. Okay, thank you. Okay. Today we'll discuss about, I think somebody asked about the demo class and verification, design verification. Okay, so based on that, I'm starting this. So here we are the Gnanodaya VLSI. We're going to discuss about what are the job opportunities in VLSI semiconductor. Okay, and we'll see the design verification also. So before that, we'll see like in the so basically in semiconductor, VLSI semiconductor. So basically, what are the companies you have means basically like one second. One second. I got a message. Okay. Okay. One second. So just I will. After completing my session, just I will provide question and answer. Any questions or queries. So during that, we will discuss these things. Okay. Just after completing the session, compulsory. I will clarify. Okay. Yes. Meanwhile, just we'll go through this. Uh, so basically, semiconductor companies are broadly that's classified into product-based companies, okay, service-based companies, and EDA companies. Okay, product-based companies are nothing but the companies which will provide which will produce the ICs like Intel, Qualcomm, AMD, okay, Nvidia, okay. So these are the product-based companies, okay, and so these product-based companies they will produce their own ICs, okay. So these are product-based companies, and service-based companies are nothing but they will not produce any ICs. They will give service related to the requirement. Okay, so they will give the service related to this requirement. Okay, those are service-based companies. Okay, one second. Yes. Okay. Hmm. So these are the service-based companies. Okay, and next. EDA companies are nothing but like Cadence, Mental Graphics, Synopsys. So EDA companies are nothing but electronic design automation. Okay, so basically like in 19 from 1971, we are dealing with a transistor like a SAS, SSI, LSI, MSI. Okay, medium scale integration, large scale integration. Okay, all those things. No, so that means suppose within an IC, suppose like 100 gates are there, or 1,000 gates are there. Manually we can do the layouts and all those things. Suppose in the IC you have like millions of transistors are there. Okay, so you can't do manual. So you want some EDA tools, okay, Cadence tools and Synopsys tools. So by using these tools, we are using in the VLSI front end and the back end. Okay, so that's why these so some tools like in the back end for the physical design we are using Cadence Synos tools. Okay, and Synopsys in the front end we are using VCS tools. And from the mental graphics for the front end, you are using for the Verilog, we are using model sim, and for system Verilog, using Quasta sim. Okay, so these are the tools they will provide by the EDA tools. Okay, EDA companies. Okay, so these three work together. Okay, these three work together. These EDA product and service-based companies will always be synchronized. Okay, they will combine. Okay, synchronize up. They will combine to meet the technology deliverable. Okay, with the support of what VLSI engineers. Okay, with the support of VLSI engineers. Okay, so this is about the companies available. Okay, and so many opportunities are there in VLSI. Okay, and so before that, I want to go with this. One second. Somebody else joining. Okay. Mm. So first, I will go with this design flow and how many types, how many engineers are required. Okay. Suppose like ASIC is nothing but application specific integrated circuit. Okay. This IC we are using only for particular application is nothing but ASIC. Okay. Suppose example in your household, you are using LED TV. LED TV, the IC is available in that LED TV that only for the TV purpose only. We can't use for other washing machine or other ACs. We can't use. Okay. So once the program is done with the thing, we can't change. Okay. So So that's why we call as this application specific integrated circuits. So basically, like when the uh, customer will come with his requirement, any IC. So IC first they will see the specification. That means that IC is means using for any signal process, okay, or it is using for the computer, okay, it is using for the computer like that, or so what is the functionality of that IC? Okay, where we are using that IC? Okay, that is nothing but specification. Okay, that is nothing but specification. One second. Okay, that is nothing but specification. Okay, and next, so that is nothing but design specification. So what is the functionality of first? Whoever the VLSI engineers are, design engineers are there, they will take the specification from the client. Okay, so that IC is using for any communication purpose, or that IC is using for any signal processing, or that IC is using for any spacecraft, or it is using for the computer related. Okay, so like that, that is nothing but specification. Okay, so that is nothing but specification. Okay, and next, so next what happens next? Next is what architecture. So architecture means, so basically, if you consider, if you want to design a CPU. Okay, so CPU means what? Before that you need to like design that architectural wise. That means, we can call it a blueprint. Okay, we can call it that. Suppose if you are constructing any building, before that you need to have the planning of that or blueprint of that building. No, so same like that. That is architecture is nothing but that is the blueprint. And if you are designing any CPU, so it consists of arithmetic logic unit, memory unit, and control unit, bus interface unit. Okay, where these blocks should be placed. That total layout. Okay, we call as this architecture. Okay. Again, micro architecture means what? Micro architecture means, these are nothing but submodules. Okay, submodules means I told you CPU. No, so CPU consists of what? CPU consists of again these what we call it consists of ALU. Okay, and control unit, and control unit, bus interface unit. All those things we need to design. Okay, so that means in the abstraction level, there is like a bottom up approach and top down approach. No? So that means we go with the top down approach only. Suppose if you consider any system is there. Okay, system is nothing but higher form. Okay, system is divided into module. Module is divided into some gates are divided into transistors. Okay, so this is top down approach. So basically we'll prefer this top down approach. So that means if we want to design any CPU, that is consist of what? ALU, memory, and bus interface unit, and control unit. Again, these modules are made with some sequential or combinational circuits, all those things. Okay, so this is micro architecture. So after that, RTL design. RTL design means basically we are using HDL ports for RTL design. Okay, so basically we are using Verilog only. Okay, Verilog is it's a universal language, and it will follow C syntax. Okay, if you are comfortable with C, and we can use this Verilog. Okay, basically they in the RTL design there are four levels of abstractions. You know, like switch level, gate level, and behavioral level, and data flow level. So basically, RTL is nothing but register transfer level. This shows how the data is transmitting through the register is nothing but RTL. Okay. So basically, we are using this behavioral level and data flow level in the RTL design. So here, RTL engineers, they will design. Okay, they will design the based on the specification. So they will design, they will write the RTL codes for their design. Okay, after that they will so if design is met, it will go to the next step. Okay, so next you need to do some verification. Okay, so verification is done, that means by using RTL also you can verify, but small modules you can verify up to FSM, up to finite state machine you can verify. But if you are going for complex IPs or SOCs, system on chip, okay, it is difficult. Okay, so you need to go for what SV, system verilog, and UPM. Okay, so system verilog and UPM. Why you are going for system verilog means some more properties are there in the system Verilog, it is having it will follow object oriented programming OOPS concept, and inheritance is there, and polymorphism is there. Okay, polymorphism is there, and next randomization is there, and constrained randomization is there. Again, this Verilog will support four-state data type. Okay, it have like a 0, 1, X, Z, but it will support two-state data type like 0 and 1. Okay, so we can develop the test bench by using SV. Okay, system Verilog. Okay, so that means 90% this SV we are using for verification only. Okay, so we can see for each and every corners of this blocks by using SV. Okay, we have and this will support a black space text bench, but this is white space text bench. So that means by using white space text bench, we can see the bugs. Okay, we can see the errors or bugs openly. Okay, that is SV. And UVM is not a. This is a language only. Okay, this is also language, and Verilog is a language. UVM is not a language. It is nothing but a methodology. Okay, I'm using a methodology. I'm using SV by in the UVM. Okay, this is one type of methodology. Okay, universal verification methodology. In this, we are using OVM. Okay, open verification methodology in this UVM. Okay, so basically, DV engineers who are the DV engineers will do this verification. Okay, ASIC DV engineer, design verification engineers will do that. So RTL engineers will write the code, and the DV engineers will verify whether your code is correct or not. Okay, and one more verification is also there, formal verification. Okay, so this is a design verification. Design verification means you need to go with you need to use system Verilog and UVM related, and you can verify your design. Formal verification means you should use some mathematical formulas. Okay, mathematical formulas to verify your circuit. Okay, so here also you want FE engineers, formal verification engineers. Okay, you want some openings are there like formal verification engineers. Okay, and next if design is met, it will go to the next state, and if design is not met, it will go again go to the RTL design. Okay, and logic synthesis is nothing but basically there is a difference between high level language and this HDL. Okay, what is the difference means high level language. So you already know high level language like C, Java, okay, Python. Okay, so these high level language they can only develop the application. Okay, they can only develop the application, but they can't create the hardware. They can't create the hardware. But by using the HDL, we can create the hardware. We can create the hardware. Okay, so that means a synthesis. That is nothing but what synthesis. Synthesis is nothing but what synthesis is. We are converting our Verilog is nothing but we already studied the digital combinational sequential half adder, full adder. That functionality you know. So you are describing that digital modules in textual format is nothing but Verilog. Okay. So whatever the HDL, so these are hardware descriptive languages. Okay, HDL. Okay, you are describing that hardware functionality of the hardware. Okay, you are converting your hardware descriptive language into gate level netlist. Gate level netlist is nothing but synthesis. Okay, so this is nothing but in terms of gates. The circuit will be in terms of gates. Okay, that is nothing but gate level netlist. Okay, this synthesis you have a synthesis engineers. Okay, so you have a synthesis engineers. Synthesis engineers what they will do? They will work on the constraints. Okay, those are area, time, and power. ATP. Okay, ATP. Area, time, and power. So why area, time, and power? So nowadays you are using handheld devices. Area should be as less as possible. And you know that Moore's law. Moore's law is nothing but the number of transistor count doubles for every 18 months or 24 months. What happens every time the transistor length, the gate length is shrinking, and now we are on working with 2 nanometer technology. The gate length is 2 nanometer technology. Every transistor we can't see with our naked eye. So by using some large equipment only, we can see that small transistor. Okay, so they need to work on area, timing. Okay, time that should be as fast as possible, and power also. It should take all our battery operated. It should take low power. During sleep, it should be like it should take low power like that. Okay, so this will be done by the synthesis engineers. Okay, and after that DFT is nothing but design for testability. So they will use some BIST or scan test. Okay, this is one type of testing whether your specification is meeting or not. Okay, whether your functionality is meeting or not, they will test. Okay, and the LEC is nothing but logic equivalence check. Okay, here also you require DFT engineers. Okay, and logic equivalency check. Logic equivalency check means nothing but logically they will verify that your functionality is meeting or not. After this logic synthesis and DFT, they will check for logic equivalency check. Okay, and next you have like a static timing analysis. Static timing analysis, you need to check for pre-layout before pre-layout and after layout, post-layout ST. Okay, so that means pre-layout ST and post-layout ST means they will deal with some delays. Okay, delays, setup time, and hold time, slack, clock skew. Okay, all these parameters are there. So they deal with the delays. Okay, timing delays and clocks. All those things they will do with the static timing analysis. Okay, so HTA engineers are also required. STA engineers are also required. Okay, and if design is not met, it will go to the next step, and if design is not met, it will go to the synthesis. So PD flow means they will do like a backend floor planning, placement, routing, and clock tree synthesis. Okay, LVS. Okay, layout versus schematic or DRC, design rule checks. All those things they will PD people will do. This is backend. Okay, so till this RTL verification and up to synthesis, this is front end only, VLS front end. Okay, so you require PD engineers. For this, you require PD engineers. Parasitic extraction means suppose RC extraction, resistor and capacitor extraction. Okay, and after this, you have post layout STA. Okay, and if design is met, it will go to the next step. If design is not met, again it will go to the PD flow. And here also you need to have the physical verification. Okay, physical verification. Okay. And after that, after physical verification, it will generate GDS2 file. GDS2 file means graphical data stream file. Okay, so this is given to the fabrication. Fabrication will do, we can do by using NVEL or twin tube process. There are some techniques are there: photolithography, ionization, ion implantation, okay, diffusion, okay, etching, okay. All these things will be taken care by fabricators. So you'll get an IC. Okay, so total you require nearly 10 requirements, 10 VLS engineers are required. Okay, this is about ASIC design flow. Is there any doubts? So that I will.
Yes, sir. Good evening, sir.
Yeah, yeah. Tell me, ask me.
Sir, you said about types of jobs in VLSI like front end and back end, right?
Hmm. Okay.
In front end, you said verification, DFT, this all. Uh,
Related to
in
this
back end,
design flow, you ask me design flow. This you can ask
only design
anything.
flow, sir.
Only
In
design
back
flow.
end,
I'm asking. Yeah.
yeah, sir, you said back end only physical design. Is there any other
In the
jobs to?
back end, physical design feeding units are there, and STA is also back end. Post layout STA, static timing analysis. Here also STA units are required, and physical verification also required. Okay, and DFT is also back end only. Okay, DFT is also back end only. So they like a testing engineers. So in the back end, you can call DFT and PD and layout engineers, analog layout engineers. Okay, and AMS, analog and mixed signal design engineers. Okay, so in the back end, you have analog layout engineers also there. Okay, analog layout. Okay, analog
Yes,
layout
sir.
engineers. Okay, and that is separate ports will be there, analog layout, and next AMS. AMS is nothing but analog and mixed signal. So analog and mixed signal means they will they will do with both analog as well as digital. Okay, some
Yes, sir.
ICs they will operate with both analog and digital signals. No, so that is analog and mixed signal. This is analog and mixed signal.
Sir, verification and testability comes under back end, right?
Verification you will get in front end as well as back end. See here, this is
Okay,
front
okay.
end. Any suppose if you are writing for any program for SOC, this DB engineers will do verification by using what SV and UVM. Okay, formal verification also they will do by using some mathematical tools. Okay, mathematical formulas and tools. Okay, that is formal verification. So after completing these total thing, that means physical verification means they are doing this some related to power area and all those things. Whether your design is meeting the specifications or not. Here also backend also verification will be there. So here you require PV engineers, physical verification.
Yes, sir. Yes, sir.
Understood? Shall I
Yes, sir.
move
Thank you,
forward?
sir.
Okay.
Yeah, yes, sir.
Okay. Okay. One second. Yeah. So our topic is this demo is a design and verification in VLSI. Basically, if you see everywhere you have VLSI. Suppose from day one onwards, you are using your VLSI devices. Suppose phone, laptop, and your household appliances also, like washing machine, TV, mobile TV, and this what ACs. Okay, household appliances. Okay, everywhere VLSI is there. Suppose automobiles. In automobiles also airbags, auto lock braking system. So each and every operation have a specific IC that is ASIC. It will do only that operation only. Okay, engine control, brake control, all those things. Okay, so and every sector, medical sector also, medical sector you have ECG, EEG, and all those medical domain electronic equipments are there. No, so inside there will be ICs are there. Those are ASIC. Those are used for specific applications. So there you are using ASIC. Everywhere you see VLSI is there. Okay. So basically, what are that means you already know about these microcontrollers and microprocessors. Microprocessors and SOCs, I told you system on chip, and FPG. FPG is nothing but field programmable gate array. Okay. So microcontrollers are nothing but you already studied about 8051 microcontroller. So that means it have like CPU, ROM, serial interface, RAM, timers, IO ports within a single IC. That is nothing but microcontroller. So if you consider 8051, that is a 40 pin IC, and it consists of 4 kilobytes of ROM and 128 bytes of RAM, and you have timers and IO ports. Okay, you have IO ports and UART, all those in a single chip. Okay, that is a microcontroller. And clock rate is 1 megahertz to 300 megahertz. So this we are using for specific application only. So microcontroller means these microcontrollers and microprocessors are general purpose. Okay, so basically, this embedded people they will do programming in the microcontrollers and microprocessors. So basically, we are the VLSI engineers. We will example if I tell we are making the brain. Okay, we are making the brain. That brain is used by the embedded devices. Okay, they will program that embedded device. So we are constructing that brain. Okay, we are making that brain, and this embedded devices using that brain means what like they are programming with some embedded C and all those things. Okay, so that is related to embedded only. But our discussion is VLSI. Okay, so this is the 1 gigahertz to 4 gigahertz like that. And next, this is basically used for specific application. It consists of a register array. I think you studied about 8086 microprocessor. That it is a 20-bit IC, and 20-bit address lines will be there, and
16.
16-bit data lines will be there, and
Yeah,
that is one Newman
20
architecture. Okay, all those things
times.
you are already studied. Okay, that is microprocessor. 1 gigahertz and 4 gigahertz clock rate will be there. So basically, in your laptop or desktop or whatever you are using, that is microprocessor. And the system on chip is nothing but you have a ARM processor and some AMBA protocols will be there like ABB, AXI, AHB. These are nothing but buses that will communicate with the internal serial bus protocols, we can call as serial bus protocols, that will communicate with the internal circuits like SRAM, flash, CAN, PWM, SPI, okay, USART, ADC, okay, all this PLL, all these are peripherals. Like I can say that suppose ICM processor, that is one SoC. I say Intel i7 processor or ARM Ryzen 7 processor, that is one as SoC. Or in embedded devices also, Raspberry Pi. Raspberry Pi is also one SoC. Okay. So all these peripherals within an IC we call as system on chip. It is acting as a system. Okay. It is acting as a one IC. It is acting as a system. That is nothing but we call as nowadays we are getting GPUs also, no, for AI related chips also we are getting, which will be produced in NVIDIA. Okay, so all those are SoC only. Gaming laptops, if you take, okay, it consists of some GPUs. Okay, so that means it should work without any delay. Okay, that should be as fast as possible. Okay, those are like SoCs. Okay, and FPGAs are nothing but field programmable gate arrays. Like we can program this. Okay, we can program this FPGA. It consists of configurable logic blocks, and so configurable logic blocks consist of some. It consists of some muxes and all those things. So here, like suppose if you want to write a program for FSM, okay, so you write the Verilog code and test bench for this FSM, and after that you can load this. Okay, you can load this and you can use for R&D purpose. Okay, so in this FPGA basically consists of SRAM. SRAM is what? SRAM is volatile. So volatile means so when power is cut down, all the contents present in this programming will be erased. Okay. So basically, these are gate arrays only. Okay, like the gate arrays we already studied about PLA, and Chrome. Okay, and next the CPLDs. CPLDs is the consist of it consists of ROM. So that means once the program is loaded in the CPLDs, this will be this will be not erased even though power is cut down. Okay, but this when the power is cut down, this FPGA that will be erased. Okay, so where you are using this FPGAs means you are using in the defense. Okay, and telecom, suppose you have towers. Okay, you have towers, no, so cell towers are there. Okay, so previously like you used 3G network, 4G network. Okay, now you are using which network? 5G network. In future you will get 6G network. Okay, suppose if you are using ASIC in these cell towers, what you need to do? Whole equipment present in the cell towers you need to remove and you need to replace new one. Okay, it becomes costly, no. Okay, it becomes costly. So when you are using FPGA, suppose in future you are getting 6G. Okay, if in future you are getting 6G, what you will do? You are using FPGA, so that means based on that my FPGA speed and requirement, I can program. Okay, in defense also, so many electronic equipments are there. Okay, so there we are using FPGA. So suppose if there any every day, means every day the technology will change. No, some more new technology comes means we can't maybe we can't replace this one. No, these are very costly. Okay, so that means we can reprogram. Okay, we can reprogram this defense purpose. We can reprogram. Okay, that's why we are using this FPGA. So basically, how we are writing this program is, so basically I told you, know, the target devices are ASIC and FPGA. ASIC is nothing but we are using only for particular application. Okay, like I told you, in household you have TV, ACs, okay, washing machine, okay, wearable devices, okay. In automobiles, you are using like engine control, brake control, and airbags. Okay. Suppose like suppose one person is using 3G mobile. Okay. So 3G mobile nowadays all are using 5G mobile. Okay. So that means what this telecom people will do, they will slow down this 3G mobile 3G network. Okay. And this 3G network you will get in villages only. Okay. And they will increase the strength of 5G. Why? Because all are using 5G network only. Okay, this person will come to the shopkeeper and he will ask, my network is slow, like that he will ask. Okay, What the shopkeeper will tell? He will tell that you need to, we can't do anything with this 3G mobile. If you want speed, you need to purchase 5G mobile. Okay. So that means this is nothing but what ASIC. It is designed only for what ASIC. This is designed only for 3G network. Okay. So if you want speed, you need to buy a new mobile that will support the 5G network. Okay. So that is the ASIC. Okay. FPGA I told you, cell towers example and defense. Okay. That is FPGA, field program gate. This is used for R&D purpose. Okay. This is used for bulk production. Once it is programmed, we can't change. Okay. Suppose if you are using ACs, this is like 5 years back. Now new ACs are coming with IoT technology and AI technology. Okay, can we program these ACs with this IoT and AI? We can't program. Why? Because this ACs consist of some operation with some remote only. But this advanced ACs we are operating with IoT. Some applications we can operate outside also. Okay, so that is nothing but ASIC, application specific integrated. We are using only for particular application. Okay, so this is FPGA flow. So basically, first you need to write the HDL, hardware descriptor language, either Verilog or VHDL. And there is a Vivado tool, Xilinx Vivado tool. Okay. Basically, Xilinx is the previous company is there, but AMD acquired that Xilinx. So now we are using Xilinx Vivado that converts HDL into schematic. Okay, netlist I told you, no. So this HDL code we can convert into gate level netlist. That is nothing but synthesis. Okay, schematic gate level netlist. And next, what you need to do? You need to do some implementation. Okay, like floor planning, placement, routing, mapping. Okay, this is nothing but implementation. Okay, so we are doing this implementation: translate, map, place, and route. Okay, so after that, so different techniques will produce different files. It will produce the NGT build, map file, pair file, all those things. Okay, and generate the bit file. It will generate the bit file. Bit file is nothing but basically our electronic processors or controllers will understand only zeros and ones, no, or hex file. This is nothing but it. This is one type of hex file only. Okay, in controllers also we are generating the hex file and we are loading into the controller. They will be depending on the application. Your controller will work. Okay, like that, same like that. You will generate the bit file, and that is FPGA bit stream that we are porting into the application. Okay, that bit file is there, that porting into the hardware based on your requirement, based on your application. If you want to like execute, 1 second. Yeah, 1 second. Am I audible? Give response. Am I audible? Yeah, give response. Am I audible? Yeah, am I audible? Yeah, yeah. Actually, there is a power shutdown. I connected with my mobile. Okay, 1 second. Okay. So this is nothing but FPGA bit flow, bit stream, and next basically there is a functional closure. Through simulation, we'll do some functional closure and power closure also, power related issues. Timing closure means for the timing related, we are doing the static timing analysis, clock domain crossing, and reset domain crossing. Clock domain crossing means the different clocks are there, how we are operating. That is nothing but clock domain crossing. And in the front end, reset is very much important. That too, we are using asynchronous active low reset. Okay. Why we are using asynchronous active low reset means when it is like going from reset mode to functional mode, that is synchronous with the clock. Okay. When it is coming from functional mode to reset mode, it is asynchronous. Okay. Suppose when you are doing this asynchronous active file is set. Both are synchronous with the clock. Okay. Suppose sometimes your clock is not working. What happens? Okay, you can't reset your circuit, no. So that's why you are using asynchronous active low reset. Okay, this studying of reset is also very much important in the DV. Okay, front end. Okay. So basically, course ever use first we will teach digital electronics and Verilog VHDL, Verilog projects project will give, okay, and HTA, static timing analysis, ADC, RDC, and linting also will teach. This is RTL design. Okay. Suppose if it is DV, design verification, will teach digital electronics, will
Sir,
be
your voice is audible, sir.
okay. I think 1 second, 1 second, 1 second. Now am I audible? 1 second. Now I'm audible. Yeah, due response. Now I'm audible. Hello. Due response. Anyone?
Sir, your voice is not audible to breaking your voice breaking, sir.
My voice is breaking. Okay. Okay. Now I'm audible.
Okay, sir.
Okay. Okay. Yeah. So this is a course overview. Design verification means we'll teach system Verilog and system Verilog assertions, and UVM will teach along with the Verilog and this verification languages and methodologies will teach. Okay. So basically, what is the difference between Verilog and VHDL means? Verilog is high-level HDL and easy syntax and easy to learn. It is came into market around 2001. Suppose if you want to design a simple AND gate is there. So AND gate means so basically how many inputs are there? Two inputs are there. Okay, like A, B, and output is what A and B. No, so basically it will start with module and module name, and in the within the bracket you need to initialize the input A comma B and output Y. I'm using a continuous assignment statement, that is I'm using the data flow modeling assign. Okay, this is a keyword Y equal to A and B and end module. So within three lines I wrote in Verilog. Okay, but if it is VHDL, do you know VHDL? VHDL is nothing but very high speed integrated circuit hardware descriptive language. Okay, this is came into market around 1999, and this is used in defense. Okay, and academics also they will use. This is hard syntax and controlled language, hard to learn and multi-level. Okay, this Verilog is universal. Wherever you go, this is universal only. Okay, wherever in the world you go for RTL design, they will use Verilog only. Okay, so if you write for this basic AND gate, you need to use the library IEEE, use the IEEE. You need to define the header file, use IEEE.std logic 1164.all. In entity, you need to declare the inputs. Okay, A in std IO logic, in std logic, B std logic, and in architecture, you need to write the program for AND gate. Okay, so how many lines of codes are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Mostly nearly 10 lines of code. Simple AND gate. It is required. It is like hard syntax and complex program is there, but it is easy to learn. Okay, Verilog is easy to learn. Okay, this shows the difference between Verilog and VHDL. So basically about the Gnanodaya, we have like it is there in two places. One is in SR Nagar, Hyderabad, and another is in Bangalore, Martali. Okay, Martali it is there. We have like 15 plus years of experience. Trainers are there. Okay, placement track record also there. Okay, we have some few students joined in so many companies in DV, PD, and analog layout. Okay, and AMS, analog and mixed signal layout, all those the domains they placed. Okay, so 100% placement will be given industry standard course curriculum, and whatever the tools are there, VPN support will be given. Okay, low cost. Okay, and 100% placement assistance will be given. Okay. And next, I told you know top companies are nothing but like Samsung, Intel, TSMC, okay, Micron, Qualcomm, Nvidia, Broadcom, MediaTek, TI, AMD, okay, Infineon. So top 20 companies product. They will produce their own ICs, like they will produce NXP, Philips, you know, Philips, NXP, analog devices, okay. These are
Yes,
top
sir.
product-based companies. These are some service-based companies also, established VLSI companies. I think you know, like Samsung, okay, L&T, okay, Wipro, okay, the Capgemini, okay. So Capgemini, they will make one drive, especially they will recruit the women's to empower the women's employment. That will be also beneficial for women's. Okay, apart from 1,000 plus service-based companies, you have 1,000 plus service-based companies in the Bangalore, Hyderabad, Noida also. Okay, and these are some listing companies. Okay, you know that Intel, Synopsys, the Tesol, Microchip, HCL, L&T. Okay, and
Qualcomm.
eligibility criteria is you need to have the BE BTech ECE triple E. Why? Because in ECE triple E only you are studying this digital electronics, analog electronics. Basic idea, if you have idea, again we are recollecting those concepts so that you will be perfect. Okay, ME, Tech, VLSI or electronics, 60% score should be there. Good communication skills will be there. Okay, and training process is registration, course fee discussion, training period, preparation with mentor support, conducting. We will conduct weekly assessments, assignments, as well as mock interviews. Okay, and also you need to give. Suppose one module is completed. Suppose digital module is completed. So we will give some topic in that, and for the period of 20 minutes, you need to discuss the concepts related to the topic, and we will assess how much your understanding level is there. Based on that, we'll give some marks. That marks will be used during the placement. During the placement, we'll take all the average, and based on that, so toppers like will filter like. So based on that, we'll send the resumes to top companies or like that. Okay, and fee structures. For more details, contact HR. Okay. Yeah, you can contact HR, and this is Gnanodaya. Uh, so this is the contact number. Yeah, any questions you can ask me. Now, any questions you can ask me. Yeah, do you have any
Sir,
questions? Yeah.
sir, in Verilog, like we are using mostly like Verilog code.
Hmm.
Like in a Verilog code, in like gates, normally in gates, how we start that like Verilog codes, basic like.
Basic that we will discuss. Suppose if you want to study Verilog, you should be strong in the digital. Digital means that to basic number systems and all those things. That digital electronics up to KMAP is digital electronics, and combinational circuits means off adder, full adder, all those things. Sequential circuits, latches,
Sequential
flip-flops,
flip-flop
flip-flops, up to FSMs
register.
will teach. FSMs will teach, and after that. There are like I told you, no, like four styles are there. Switch level. Switch level means what? We'll design with a transistor, CMOS level. Okay.
Okay.
Gate level means gate level modeling. Gate level modeling means with help of gates we'll write the program. Suppose AND gate is there. Okay. AND gate means what? So AND gate means it consists of inputs Y, output A, B. Okay. There are some primitives, gate level primitives are there like AND or not. Okay, so like we'll write the syntax and gate level primitive A1 and output and input like that we'll write. Okay, that but this is not synthesizable. Okay, basically we are using data flow only. Data flow means in terms of expression. So expressions we'll write. Okay, like suppose half adder is there. What is sum
Yes.
A XOR B, no? And
A
carry
for
equal to what? AB.
A,
Okay.
AB.
This we are using a assign statement. Okay. And behavioral modeling also we are using. Okay. In RTL, you are using behavioral modeling or data flow modeling or hybrid modeling also you are using. Both combinedly we are
Structural
using.
modeling. Structural modeling also.
Structural modeling is we are not using.
We
Only
in
data flow.
Verilog, like in
Verilog we are not using. Data flow modeling and behavioral modeling we are
bench
using.
and normally data flow, right?
Yes, data flow. Yes, yes.
Yes. Only both two codes only we are writing, right, sir?
Yeah, yeah. Two codes only. Why? Because these are synthesizable. Means what we can convert into hardware.
Yes, sir.
Okay.
Okay.
We are using some procedural assignments like if case and while repeat in behavioral modeling. And we are
Okay.
writing in always no always block, always
Yes,
sensitivity list, and
accurate.
initial is not synthesizable. Initial block is not synthesizable. We need to write in always only. Okay, that is synthesizable.
Okay,
Okay,
okay.
okay. If you join means
Sir,
in detail we will discuss. Okay. Tell me.
yeah,
Yes.
yes, sir. It's fine.
Yes.
Sir, can you explain me about FSM, finite state machine? This one only last question. State machine, sir.
One second. Okay. Finite state machine. Finite state machine is
Yes, sir.
nothing but basically like you have like a Mealy machine and Moore machine. Okay. So
Yes, sir.
Mealy machine means but what so in the name itself it is there like finite state machine is nothing but it consists of finite number of states. Finite number of
Yes.
states. Okay. Basically it consists of Mealy machine and Moore machine. Mealy machine is nothing but the output depends on the present state and present input. Whereas Moore machine
Mm,
is nothing but output depends only on the present state. Okay.
mm,
So we can design a sequence detector. Okay. In that
mm.
sequence detector also, like if you want to detect 101 sequence or 1010 sequence, you need to start with 2 bit. 2 bit means how many possible combinations? Four possible combinations, and you need to draw for Mealy machine and Moore machine. Okay. Overlapping and
Yes.
non-overlapping. Okay. And
Yes.
we can design the serial adder also. We can design the
Yes.
serial adder also. Serial adder means like basically you studied about carry looked adder, no? Carry looked adder,
Very
RCA,
look. Yes, sir.
ripple carry adder, carry looked adder, then BCD adder. This is in
Okay, sir.
combinational circuit you studied. These are nothing but what parallel adders. These are
Parallel
nothing but
order.
parallel adders.
Correct.
Okay. Suppose if you want to design serial adder, suppose one bit that will be stored in the shift register, and you are designing some D flip flop. One bit you are adding. 0 plus 1 is 1 you are adding, and you are storing in the shift register. Okay. So that means
Mm.
the requirement is speed is not that much important for you, and cost is less. Wherever you want less cost, you want to design an adder, you can go with serial adder.
Okay.
Suppose RCA, 4-bit RCA is there. 4-bit RCA, how many full adders are required? Four full
Four.
adders are required, no? Circuit complexity
Yes.
is increasing, no? Speed is fast
Yes.
only, okay? Carry look at adder, speed is fast only, okay? Here the speed is slow. So you are compromising with the speed means you can go for serial adder. That you are designing with FSM, finite state machine.
Yeah.
Lift is also FSM, no? Lift. Lift is also FSM.
Yes.
Suppose if
Lift.
you are there in the third floor, okay, fourth
Yeah.
floor person has that he presses the button, okay. So that
Yes.
means it will not go to the ground floor, no. First it will go to the fourth floor. He will
First.
pick up the
Yes.
fourth floor person, and it will come to the first floor, okay. So many
Yes, sir.
applications are there in the FSM, like traffic light and vending machine, lift, and all those things
In
applications.
conclusion point, the finite state machine follows only like serially and parallelly type of data, right? Okay.
No, like it will follow some sequence.
Okay. Okay. Sir.
It will follow some sequence, not serial and parallel. It will follow some sequence. Okay.
Yes, sir.
Suppose like suppose if you sequence detector if you take 0 0 you want to make. Okay. So
Mm.
some Mealy machine if you draw S naught S naught. So Mealy machine means what? So this is non-overlapping if you take. So I'm checking for what S naught. So I'm checking for 0 means what? So 0 means I got this sequence. It will go to next sequence. Okay.
Zero
So
one.
this is 0 by 0. If you are not getting sequence, it will be in the same state like this. Okay. 1 by 0. And at S1, if it is you are getting 1 means it will go to S naught. Okay. 1 by 0. If it
Okay.
is 0 means it will be the same state. You got the sequence, output becomes 1. Okay. Like this. Some
Okay. Okay.
sequence. It will follow some sequence.
Okay, sir.
Okay.
Fine. Sir,
Tell me.
అది ఒకటి అడుగుదాం అనుకుంటున్నాను సార్. వేద ఐఐటి గురించి మీకు తెలుసు కదా సార్?
Okay,
లైక్
yes.
వేద రిలేటెడ్ లైక్ ఏమైనా టాపిక్స్ ఏమైనా అంటే గ్రూప్ లో ఏమైనా షేర్ చేయగలుగుతారా? లైక్ ఏమైనా లైక్ ప్రాక్టిక్స్ క్వశ్చన్స్ ఏమైనా ఉంటే
Okay.
బేస్డ్ ఆన్ డిజిటల్
You
ఎలక్ట్రానిక్.
joined this Gnanodaya, or you are looking for that?
No, no, sir. Like Veda IIT exam, I am looking to like coaching centers,
Right.
like
Okay.
three
Okay.
coaching centers, like Veda IIT. I am trying
That
to
you need
get
to
that.
discuss with the HR, and we need to take the confirmation from our higher officials.
Okay.
Okay.
Yeah, yeah.
Yeah.
Thank you,
Yeah.
sir. Thank you so much, sir.
Okay. Very
Yeah.
good. Welcome. Anyone having the doubt or queries? So shall I wind up? Any doubts or any queries?
Yes.
Okay. Otherwise,
No, sir.
uh, okay. So how you feel this demo class? Any positive or negative feedback?
Yeah. Positive feedback, sir. Really very easy way to understand the topics.
Okay.
Not
Hmm.
only the theoretical topics and practical way you are giving like examples, really in based on examples we are easy to understand very fastly.
Okay. Yes, yes. Okay.
It is not
Okay.
a boring type of
Hmm. Yeah, it will
theory.
be interesting and
Your explanation is
yeah.
understandable
Any
and easy to
concept
follow.
also, like you need to study with
Yes, sir.
both real-time examples and real-life examples, so that
Yes,
you
sir.
can understand the
It's
concepts
mostly
for more time. Yeah. Okay. More time.
yeah. Now only you
Uh,
said the examples through that I remembering it, sir.
Yes. So many sources you got. You can use AI like Copilot or like Perplexity or ChatGPT. So many AIs are came. Any topic is there, just search with the topic and school level explanation. It will give beautiful topic. You can make document. Okay.
Yes,
Afterwards, if
yes,
you
sir.
search, you will not get the same topic. So any topic. Okay. Yeah. You ask AI. Okay. So it will filter so many sites, and it will give the perfect example. Okay.
Yeah,
Okay.
yes, sir. Yes.
Okay.
Thank
Okay.
you, sir. Thank you
Okay
so
then.
much.
Okay. Okay.
Can I leave,
Welcome.
sir?
Yeah. Okay. Hmm? Okay. We'll wind up.